Chapter 13 of sdm4 is the beginning of part 3, and it really represents a shift in how the book is really structured and how the course is proceeding. It's called From Randomness to Probability, and it builds on some of the ideas from the chapter 10 in Random Variables to think about random phenomena and modeling of probability. This is a place where the course does have a different feel to it. It's thinking about developing a mathematical language for probability and starting to use that in ways to answer interesting questions as we formalize our inferences. So take a step back if you're finding this a little bit rough. Work through, definitely take some notes as you proceed. Work through as many of the practice problems as you can as a way of really grounding your understanding. This is fundamental for what we're going to be moving towards sampling distributions and then the ideas of inference in the later part of the book. So the chapter begins with a section on random phenomena and then thinks about the development of those over time and this idea that the accumulative percentage of time is green will settle down. This is something we call the law of large numbers, and we'll formalize that a little bit later. We need to bring in important ideas of trials, outcomes, events, and sample spaces. We can then think about this more formally, the law of large numbers, and Jacob Bernoulli, how this differs from the non-existent law of averages, and begin then to start to model probability more formally in terms of theoretical probability. This we can be thinking about in terms of counting notation and how hard can counting be, and it turns out it can be very, very challenging. It's also challenging is aspects of psychological probability or subjective or personal probability. A lot of things aren't what they appear, and a guidance here in the book is one I will reiterate. First 3 rules for working with probability: make a picture, make a picture, make a picture. As we start to introduce these rules, these are definitely things you want to go ahead and be jotting down. There are just a couple of rules that define all aspects of probability. First is that probabilities are between 0 and 1. The second rule is that all probabilities have to occur, so the probability of all possible things is 1. And that either something happens or it doesn't, the complement rule. Rule 4 introduces the idea of the addition rule for disjoint probabilities. We'll generalize that a little bit. And then think about Rule 5 for the multiplication rule, that the probability of A and B is just equal to the probability of A and probability of B, provided that those are actually independent, something we'll talk about in just a minute. So we can apply the multiplication rule. Again, practice is really important here, kind of working through these, and the just checking will, as always, leave you in a good position. The example with M&Ms, I'm not wild about M&M examples. I think there's more interesting examples, but this is useful to kind of be thinking about a specific setup. Lots of ways we can go wrong with probability, and so kind of it's worthwhile reading this and the connections. And finally, the learning outcomes, and these rules are restated in a very terse fashion. This chapter on probability, again, very helpful foundation for moving in terms of later statistics.